Good morning students. Welcome to the new computer learning session. In today's session, we will learn about computer memory. So let's start. Firstly, we will understand the meaning of memory. As you all know that we all have memory in which we keep the things that we need to remember all the time, right? But many a times we forget many things. This is because it is very difficult for us to keep all the things in our memory. So similarly, we all know that computer also keeps many things inside us. Computer keeps all the pictures, videos, documents, and whatever we put inside the computer, computer keeps all those things, right? So where does the computer store all these things? It also have a computer memory where it stores all the things, right? Now here from the picture only you can depict that whose memory is greater. As we can see here, human memory is smaller than a computer memory. It means computer can store a lot more data as compared to the human memory, right? So before moving ahead, I would like to recall that on what principle a computer works. As we have learned in the first chapter also, that computer works on the principle input, process, output, right? It means we give input to the computer, computer processes that input, and then computer gives us the output, right? So here let us understand where does the computer needs the memory. So from this cycle only we will understand that what is the importance of memory for the computer. So as I said, we give input to the computer, it means we are giving data to the computer. And computer is taking that data from us, then computer is keeping that data inside the memory. So here computer needs the memory. For what purpose? For keeping the data that the computer has taken from us. For keeping this data into the memory, computer needs the memory, right? Now from this memory the data goes for processing. Now while being processed, the computer again needs the memory here, because everything that is being processed inside the computer, all these things resides inside the computer memory. And once the data is being processed, it comes out of the memory and it becomes information. Now that information is again stored inside the computer memory, and then it is given to us in the form of output. Now this is how the computer works, and this is why the computer needs the memory. So now let's move ahead and understand more about computer memory. So computer memory consists of electronic components, one or more chips on the motherboard. As you can see here in the picture, this green board is having the 4 chips, 4 black chips on it. So these small chips are the memory, right? And where this memory is located? It is located inside the motherboard. In the previous chapter only we have seen the motherboard. Here again let us see the picture of the motherboard. This is the picture of the motherboard, and these green plates that you can see in the picture, these plates are the plates, these plates are the chips actually, which are your memory chips. Now let us move ahead. Computer does not understand our language. As we all know, the way we speak like English or in Hindi, computer cannot understand our language. Then what does it understand? It understands only 2 digits, 0 and 1, right? So computer understands only one language, and in that language there are only two digits. The first digit is 0 and the second digit is 1. Now let us understand how we can get to know that how much memory a computer have. As we all know that to measure the weight, for measuring the weight of something, we use the gram and kilogram, right? So similarly, if we have to measure the computer memory, that how much memory does a computer has, we use bits and bytes. So these two units, these two terms are used for measuring the computer memory. So let us know more about it. First of all, what is a bit? Bit means binary digit, and binary digits means only two digits, 0 and 1. So bit is the smallest unit of data that a computer can use. Means if there is a 0, it means 1 bit. If there is a 1, it also means 1 bit. So it means bit means only two digits, that is 0 and 1. And bit is the smallest unit of data that a computer can use. Now let us move further. What is a byte? So students, byte is the basic storage unit in memory. Means everything, every data which is present inside your system, it is present in terms of bytes. As we have studied earlier that computer needs to store data inside the storage devices. So whatever the data is present inside the storage devices, all that data is present in terms of bytes. Like 2 bytes of data is stored or 3 bytes of data is stored. Alright. Now a byte is equal to 8 bits. It means if we have 8 bits, like as you can see in the picture, it is 0, 1, 0, 1, 0, 1, 1 and 0. So if you count it, these are 8 bits, and if we combine these 8 bits, it will become 1 byte. So now from here you can see that which is greater, a byte is greater, because when we are combining 8 bits, then we are getting 1 byte, right? So let us understand it more. Also students, 1 byte is equal to 1 character. What does it mean? Means whenever you are writing any character on the computer, so for storing that one character, a computer needs 1 byte. If you are writing 2 characters in the computer, for storing those 2 characters, computer needs 2 bytes. Now what is a character? So students, a character can be anything. It can be a letter, means suppose you are writing A, B, C, D on the computer, or you are writing any number on the computer, or you are writing any symbol on the computer. So if you are writing any of these 3, it means you are writing a character on the symbol. Sorry, it means you are writing a character on the computer. And for storing those characters, computer needs the memory in terms of bytes. Suppose you are writing 4 characters, so computer will need 4 bytes of memory to store the 4 characters. Alright, so this is about a byte. Now let us understand some more units of memory. 1 kilobyte is equal to 1024 bytes. It means it is approximately equal to the 1 page of your textbook. As in your textbook, in the single page of your textbook, there might be 1024 characters approximately written in it. So it will be equal to, for storing that 1 page of your textbook, it will require 1 kilobyte of memory. Similarly, if we move ahead, there is 1 megabyte. So 1 megabyte is equal to 1024 kilobytes. and it is approximately equal to one complete book. It means all the characters that are written in a single book, for storing all those characters, a computer requires 1 megabyte of memory. Alright, and the next one is 1 gigabyte. 1 gigabyte is equal to 1024 megabytes, and it is approximately equal to 3 to 4 books that are available to you. It means if we combine all the characters that are written in the 3 to 4 books, then for storing all those characters, a computer needs 1 gigabyte of memory. Similarly, there is 1 terabyte, which is equal to 1024 gigabytes, and it is approximately equal to the stand of book that is having a lot of books in it. So, if we combine all the characters that are written in all these books, then for storing all these characters, a computer requires 1 terabyte of memory. Likewise goes for 1 petabyte also, which is equal to 1024 terabytes, and it is approximately equal to the room full of books. So, for storing all the characters that are written inside the books that are present in your room, so when we combine all these characters and for storing all these characters, a computer requires 1 petabyte of memory. Similarly, there are some more units. As I said, 8 bits, when 8 bits are combined, it becomes 1 byte. So, when 4 bits are combined, it becomes 1 nibble. So, these terms you have to remember it. Alright students. So, similarly, there are some more units of memory. 1 exabyte is equal to 1024 petabytes. 1 zettabyte is equal to 1024 exabyte. 1 yottabyte is equal to 1024 zettabyte, and 1 brontobyte is equal to 1024 yottabytes. Alright. In our next session, we will learn about what are the different types of memories that are present inside the computer. So, this is all for today. Thank you students.